Welcome back. Hello. So I went ahead and completed day 13 because I had some more time yesterday in here and there, and the answer was very simple actually, because this was a linear equation. Took some time to do the conversion because I didn't have pen and paper, so I used the board. But after a while, it wasn't that bad, so also very nostalgic for the school. Let's first off fix this would be day 13. Second off, it could have been solved with matrices, but at the end of the day, it's potato potato because matrices are sorry, what? Brother, this is a curious bag. Guess we're going to force this a little bit. God damn it, man. I'm gonna do it then from the tablet. Alrighty. Okay, so the day 14 it is. Let me keep my Twitch over here. Let's keep ChatGPT out. This is not needed. So I'm getting closer to my senior. My friend, so I knew this was going to be resistance uh, attrition war. I knew most of them won't survive that long. So let's see. My senior went up until day 16 and he started to say that he didn't even get what's going on. Oh, by the way, so the first approach would be linear equation. The second approach that I thought would be matrices, but again, it's linear equation, so it's either going to be Cramer or reductions, and which again would be the same thing, just probably less hard to understand, perhaps. And the last one that my senior thought is binary search. And the way that I believe I would do binary search would be basically this is your number divided by half and do the percentile from one of, so this we have number one, number two, and price. My guess, and I'm gonna ask him today, would be that if you divide the number by two and you try to do price times 2 times n and check uh, is this even or not, and based on the fact that if it's 0 or 1 you're gonna then go here, 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 until you either don't find anything or until you find something that is divisible by him. Then you take, let's say, this portion, then we take this portion and check if it's divisible by number 2. Like, this is how I guess I would do it. So this way you're gonna have log n time, so shouldn't take that long. I'm gonna ask him. That's interesting stuff. So this looks like a maid's restroom redoubt. Okay, in the meantime, let me push this because I don't believe I pushed it. As a matter of fact, I didn't. So we can drop all of this. And be day 13, part 2 done. Okay, very well. Now time to copy my input. I'm gonna do it now, but I thought I should be taking the input from the main to which one I run. So I don't want to do it at this time, but I want to fix it some way soon, somewhat soon. Day 14. Very well. One of historians needs to use the bathroom. Fortunately, you know there is a bathroom near an unvisited location on their list, and so you're all quick teleported directly to the lobby of Easter Bunny headquarters. Unfortunately, EPHQ seems to have improved bathroom security again after your last visit. Bathroom security. The area outside the bathroom is swarming with robots. Oh, this is the robot one. To get the historian safely to the bathroom, you need a way to predict where the robots will be in the future. Fortunately, they seem to be moving the tile floor in predictable straight lines. You make a list, you put the input of all of robots currently position P and velocity V, one robot per line, for example. So this is a position, this is 3 minus 3. Okay, so this would be this velocity and direction. Okay. Each robot position is given as PXY, where X represents the number of tiles the robot is from the left wall. And Y represents the number of tiles at the top wall when viewed from above. I don't know why he inverted X and Y. The position of P 00 means the robot is all the way in the top left corner. Each robot velocity is given by xy, where x and y are all given in tiles per second. Positive means the robot is moving down to the right. Positive x means the robot is moving to the right, and positive y means the robot is moving down. So velocity of 1 minus 2 means that each second the robot moves one tile to the right and 2 tiles up. The robot outside the actual bathroom are in a space which is 101 tiles wide and 101 and 103 tiles tall. However, in this example, the robots are in a space which is only 11 tiles wide and 7 tiles tall. The robots are good at navigating over and under each other due to a combination of springs, extendable legs, and quadcopters, so they can share the same title and don't interact with each other. Visually, the number of the robots on each tile in this example looks like this. 1, 1, 2, so I guess how many there are on a tile. These robots have a unique feature for the maximum bathroom security. They can teleport. When a robot would run into an edge on the space they're in, they instead teleport to the other side, effectively wrapping around the edge. Here is what robot 2-4 velocity to minus 3 does the first few seconds. It's just that I can't wait much longer, so you don't have to simulate the robots for very long. Where there will be robots after 100 seconds? In the above example, the number of each tile after 100 seconds and the lap looks like this. So then the safest area, count the number of robots in each quadrant. After 100 seconds, robots are exactly in the middle, horizontal or vertical. Don't count them as being a quadrant. So the only relevant robots are. Then the safest area, count the number of robots in each quadrant after 100 seconds. In the mid, robots are exactly in the middle, horizontal or vertical. Don't count as being in any quadrant. So the only relevant robots are. In example, the quadrant contains 1, 3, 4, and 1 robot. Multiplying this together gives a total of factor of 12. Predict the motion of the robots in your list within a space which is 101 tiles and wide and 103 tiles tall. What will the safety factor be after 100 seconds? Okay, I understand the input. I didn't get the last part. This is kind of stronger, so I don't. In the above example, the number of robots which side after 100 seconds, the lap looks like this. in the safest area, count the number of robots in each quadrant after 100 seconds. Robots that are exactly in the middle, horizontal or vertical, don't count as being in a quadrant. So the only relevant row. Okay, so there's no. So there's. Okay, so there's a cross in the middle. So don't count them as being in any quadrant. So the only relevant robots are this one. Okay. This is my example input. Yeah, I might get some nice stuff, which I'm then gonna copy for the template. Or I should fix first the template and then fix everything else. Yeah, I'm gonna do this safety here and then I'm gonna push it with the template, which would be at this point I'm gonna run it down with print twice. So, right, okay. Well, I guess part one and part one. Okay. The second thing that I want to do is take inputs arguments main Rust. Okay. There you go. If I say 1, it's going to be a 1. If I say 2, it's going to be a 2. So that is easy as that. So if args 1 equals 1, then is this. Args equals 2, then is this. Of course, arch means this is not a string. Well, kind of confusing, but okay. Hello from part 1, hello from part 2, and maybe I'm just gonna print out type 1 for pass either 1 or 2 as args. I'm gonna copy this up, go back to my template. Import this, go into part 2, fix part 2. There you go. We can close this up and we're back in business. All right, so here it is. Oh, Okay. Now this feels way better. At this point, parsing up this idea. The only thing that gets me kind of upset is that x and y are inverted. So I have to be very careful about that. X is actually y, and y is actually x. So I guess I can invert, but kind of, because if I remember correctly, the space which I was given, so take a look, is going to be 101 and 103. So that's not nice. Well, let's see how bad this actually is. Another thing that I wanted to add to show the benefit from having it most days. In this case, I'm just gonna copy it. Because in day 13, I thought to myself, there are a bunch of operations that I do that I don't need them to be this way. And they're very simple to implement. That would be that. Yes, I'm going to display the coordinate. I'm going to modify every single F64, in this case to an I64. I don't need to divide. A G. And I'm fine for display. I'm fine for add. Don't think I need reminder. I need sub. That's good. Don't think I need division. Okay, and little by little we're going to complete, because I need regexes this time. Probably not, but you know, it's going to be faster. Don't quite care to not use least power in this case. Right, so the first thing I would want to do is part this bad boy up. This is going to be a quite simple regex. I was thinking, if I invert all of this, isn't it going to be easier for me? Yeah, I'm gonna invert them. But in the meantime, let's take a look at the parsing by copying once more. I'm just gonna copy this, because I know that there are going to be 4 numbers per line. Maybe I make it in a function. So if line is empty, I don't care. I can get the match and do all of this stuff, since I presume, or since I know that the output is correct. But this would be a function, would be like get num. Can it also be a loop? It's not worth the trouble. Get num, or function get num, and we'll just give the input of line. So can I loop over the matches? Alright. The number regex. Take this up. For mat in matches, must be a capture, so I don't need to take the so the captures are at the same time another one, so would be for capping captures or in mat. Let's say like caps for capping caps. Can either and that's an option match, which then can be as an yeah, but I need control over this. Tell you what, fuck this. Get nums. I'll take the line and it will return two coordinates. Okay. Get over here. Also, you get down here. Then we're gonna tree paste it here. I'm gonna call it. This should be X, but I'm gonna call it Y, and vice versa. And the return will be chord XM, XYM, and XM, and be XY and chord of XM, YM. Very well. The line is obviously going to be a string. And then that would mean I'm gonna make two inputs that would be positions. Naturally, it's going to be a vec and movement speed. Now my TMP is going to be get nums line. Expecting str found str I can deal with this kind of way. Very well. So TMP is a tuple of chords. Well, then mean positions. It means temp temporal.0. New.word push tmp.0 and speed.push is tmp.1. Of course, I forget every time to say it's immutable. And we can now push it up to see what's going on here. Kind of. Kind of overkill, but so now it's an x and y instead of being a y and x. Same goes for the movement. Why is this not a minus? Oh no. Oh damn. I think I can do this. Regex. I think I can do this because as of now I'm just saying /d plus. And that's okay. This will get 12, but not minus 12. But if I qualify, let's say, the minus, then this will get the minus characters. If I say the capture group will gain minus time plus times. Yeah, minus star looks like it's working. Because if I remember correctly, you could say that minus star would be, hey, everything from minus to there plus coordinates looks good. Yep. Okay. At this point, now we have the coordinates, the quadrants. It's said to be, in my example input, robots outside the actual buffer are in a space which is 101 and 103 tall. However, this example robots in a space is only 11 and 7. Let's put some constants over here. How? I never use constants in Rust. Const height equals 11. And rows 7. Missing type U32, since we don't need those many bytes. Very well. And this should be able to be also outside right here. Yeah. Very well. The robots are good at navigating the hover under each other due to a combination of springs. Yes, and that would mean where will be the robots after 100 seconds? So I'm just gonna add 100 times the values. But then I need to check every time if I'm out of bounds. The out of bounds part is not that easy. So let's start with setting up the problem with the out of bounds. The precise problem. The precise problem with the out of bounds. Like, let's think about it a little bit on pen and paper. That would be, let's take a simple one. very well. So let's say that I subtract, so this is 0, and to be at 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Okay. The only hard part is if I say -1 over here, I need to start from the maximum over here. So this is the easiest case. Like if I'm in a corner, I'm in a corner. Well, actually not, because I'm not in a... Yeah, the part... So this is a kind of bastard thing, because I'm not in a corner. I'm a little bit... actually longer than that. If I remember correctly, here it was said that... So you said that it's 7, 11. So let's add one more. So yeah, there's more calls. Hello, how's the OC going? We managed to do yesterday day 13. It was kinda quite easy, actually. I just just forgot high school math. And today we're day 14, which is kinda hard. It's a bit tricky. How's yours going? If I remember correctly, you told me you were on day 4... No, 7... I don't remember. I think you skipped a couple. I forgot you were struggling on day... You were struggling like day 11 part 2 and day 7 part 2. I've skipped some part 2s. Makes sense. Same thing is doing my senior here. He skipped day 6 because Ruby can't compute that. He did some wacky shit on day 3, so day 13. And 11 is just a pain. And 11 is terrible. Okay, so what if the robot gets out of you? Because if the robot gets out vertically, so he comes back vertically, this is not a big deal. Same thing with horizontal. If I get outside here and I go back from here, that's not a big deal. Diagonally speaking, if I'm moving out from a diagonal, I don't have working solutions for part 2 on day 9, 12, 13, 14, 15, 16, and 18 yet. Oh yeah, so you're sprinting part 1 and then part 2 is a work afterwards. I can respect that. I think this is the smartest approach. Unfortunately, I'm not smart, so I'm gonna do the pain approach. Because I figured either way, I'm going in vacation, yes, since Sunday, so 21. I'm gonna skip like a couple of days of programming. Then there's Christmas, and perhaps on 26 I'm also away. So I figured I'm gonna still lag behind. Let's just deal with it how it is. If I don't get part 2 done an hour or so after the next day comes out, I put aside the work then later. That's a good rule. That's a good rule. I mean, in general, I solved a lot of part 2s, like maybe worked on it a couple of hours the first day. Then the next day, either I solved it or I did some major breakthroughs, because after a while you're still looking at the problem the same eyes and it doesn't work. Just simply wasting time. Okay, so it will be different, because if I say -1, now that's... Yeah, how do I say start from here? Should draw the... Like also... So -1, I know from my brain that it should start... Actually, I don't know where it should start. Well, it should start over here, right? So I can treat it like that. What if -1 is going to be, so you're going to go into the last row. Oh yeah, so let's say it's a -1 over 0. So he's going last row, last call, so he will start over here. Yeah, this is the most sensible one. So every time, so should subtract, so every minus extra should be then taken out, so the difference should be taken out from the maximum. And here we go. Okay, I think I got it. Now, about the rows and calls, I should be all straight because this problem is a page for the mix and mashing X and Y. I think I can get this part one. Shouldn't be too hard. I can see this going very well. So I see you did part 2 on day. Oh, actually, you didn't do on day 13. I have, if you're curious, I have 3 approaches which I told before. But what's your strategy for day 13 part 2? Out of curiosity, because if you're in some edge cases, I'm supposing you've used some of the more wackier strategy. I have 3 strategies, which are actually 2 because the 2 math ones are actually the same thing, but have different names. Let's do it starting from 5. From I. Let's make it outside. So for I in 0 up to 5, we will going to make move robots. The move robots would take in my positions and my speed. I haven't put much thought into data part 2 yet, but I'm assuming there's some math trickery that you can do to reduce the number of iterations you need. Okay. Yeah, there's a math there. You can go the math way and you can also go the programming way, which is very wacky. Actually, my senior told me about how his programming idea, and I find it so fascinating that I want to give it a try because it looks so good. I don't know why does he doing like that. I'm not gonna return anything because I don't need to. What's the... Oh yes, I have to count them in the quadrants. I'm gonna return like the partial count. No, I don't think I will. I'm just gonna change it like that. I don't want to hear too much info on other people approaches that until I either solve it or give up and not looking for it. Yeah, I respect that. I'm not gonna tell you anything. I'm the same. Until I have at least an idea that I'm following. Because lots of time it will be yeah, this sucks. And sum equals 0. That's more than respectable as an approach, absolutely. Also because you get to learn something, and every time that you think hard about a problem, when you actually get around to do it, you're gonna learn a lot. So that's the best idea. Either way, you have my repo, so you can always take a look. Mm, my son, mute off. What does Rust do as per usual? An I32. I can't say since the sum I can just go on U32. Should be more than good enough. Nice. Yeah, if I reach the point where I feel like I'm really stuck, I might go and at least look for hints as to approach to use. Yeah, if I don't see any way, any approach that rings a bell, I'm gonna try to look high, uh, the uh, the abstract way of doing it, like the definition in words. If I can put them in words, I'm gonna just take a look around and see what do people in a worldly manner think that this will be solved. Because I remember being very stuck on day 7 because of that. Yeah, day 7 or day 9? Nope, it was day 9. I was very stuck on day 9 because I couldn't. Dude, it's not even 9. Well, whatever. It was the day where you need to sum up the operation. Yes, it was 7 actually. I was very stuck on 7 because I didn't know how to get every possible combination. And I couldn't. I wanted to do a recursion, but it didn't work. So I used binary and ternary. But then I managed to use recursion on day 13, which makes me happy. Because I think you were yesterday here, so part 1 was recursion. So this I'm happy that I get to use some binary tree stuff because that I struggled a lot in college with that. And it feels bad to not yet be able to do it. Then there will be 3 kinds of the recursive solution for day 7. Yeah, there you go. That probably was a nice day to go do some recursions. It actually probably was even better than mine because you could. Mine was kinda slow because there's a lot of trial and error which were not needed. Like the recursion I did my friend, also because recursion will you can do a DFS and quit like uh, you can quit way before, because if you're gonna do all the pluses ahead of time, then you're gonna do all the times. It's faster and at the same time you're gonna quit way earlier. So that was way smarter than mine, but it was fun. Actually, you never thought about as a binary as a way to generate not random, but generate possibilities. So for e in, up to 5 for now, that would be so every time I'm gonna sum up the positions. And if should check if it's 0, I should subtract from the maximum, and if it's 1, I should subtract from the, and if it's 1, if it's maximum, I should add to the 0. Setting up my module for day 19 now. Well, see you later, hopefully. So that would be like that. How many positions do I have? Yeah, I need to iterate only on the positions. So for pause in positions, I can pause plus equals speeds. Mute. I'm gonna make the plus add here. The other sign, other sign. God damn it. Oh, self dot 0. Okay. Behind the reference. Not borrow positions beautiful is behind the at the reference. At the reference. Oh, my bad. There you go. Okay. At this point, if position is greater, so if pos.0 is less than 0, then pos.0 is equal to, so 0 would be my rows, therefore is rows plus, so that would be like plus equal rows. Now 0 to 1 calls. Okay, this is part 1. This is part 2. Now I'm gonna copy both of them actually. And if this is bigger than rows, then it's going to be minus equal rows. And same here with calls. It's bigger than calls is minus equal calls. Okay. Don't care about this because this is just a number of iterations. So this will give me the iteration. Then I would have to count it out like the quadrants. So he counts here after therefore I can count it up to 100. First off, does this run in feasible time? Looks like it does. Now I can iterate over the elements and just check if it's not in the middle. I mean, it doesn't matter if my matrix is inverted because at the end of the day, it's still in some quadrant, so shouldn't be pretty much no difference. So I don't need to do this. I can just return the sum. So let mid row. It's going to be rows halved. Let mid calls are the calls halved. Very well. Then for pause in positions, we will simply say if pause that 0 is less than mid row and pause that 1 is more than mid row, or it's less than calls row. So this will be let quadrants. Maybe a U32 3 times. So quadrant 0 is going to be plus equal 1. I can then go 0, 0, 0. All of that is not going to help me out very much. Then quadrant 2 would be less than mid row, more than rows. Not that it matters that much, just have to be different. And so it's going to be vice versa. And all of this is going to be the last one. Okay, sum quadrant. Okay, quadrant dot sum dot iter sum a tuple Rust. I guess I can't. No, dude, please. Okay. Well, excuse me 1 second. I'm gonna run to the bathroom. I don't think this should be a tuple at this point. This could be like a vec of 4 zeros. This will become like that. Okay. There you go. And now we can just say quadr.sum. .iter.sum. There you go. Honestly, let's spin it up. Index out of bound. The len is 0, but the index is 2. 95. Just make a vec of 4 elements. Oh, it's vice versa. It's 0, 4. Sum is 9. Actually, I should multiply them. Is it like reduce? Okay. Reduce elements of single one by repeating a prior reduction. Should be like arc I and plus. Okay. It would be like arc L arc times L unwrap. No, unwrap. Expect the editor found items. Borrowing where? Expected at ein32. Now this is curious. Also, this is what it wants. Use into iter instead of iter. The references in I should think. Oh. God damn it. Thanks, man. And also high null of space. Okay. About now. 0. Well then, time to draw them up. I wished to not draw them up, but it's because I have to invert the matrix. After 100 seconds, this is what it looks like. But perhaps I can just print out what the position is in the inverted position and check out that it works with the example. So let's print out the chord. Oh my bad. Pos.1, pos.0. Actually, I should qualify the quadrants. So quad 1. Everyone is in quad 1. Did I? Well, classic misplay. So no one is in quad 1, which is bad. Also, is 11 a valid one? It would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, this should be like a less than 0. What the fuck is this? No. Less than 0. If it's more or equal, and more or equal. Equal more, I guess. And there you go. Now I should just get the puzzle input. So this would be then 101 and 103. Back to copying this. This is what we're getting. Just waiting for the parts for the reaction. Uh-oh. I'm in danger. Too low. Now hold your horses. Not good. So let's put it up in my trusty bad outputs. Low outputs. Did I got the correct column and rows? Just to do one preliminary check. In a space within 101 tiles wide and 103 tiles tall. Yeah, I perhaps inverted it. In worth a try, just to see if it's different. Cut output. It is different. Okay. Classic misplay. You're making me scared. I'm gonna push before doing anything else. Part 2 usually hurt a lot. So, dude, G can do this. Also, most of day 14, except my output, which I don't care anymore. Unstage. Looks good. And this is day 14, part 1 done. Easy as that. Part 2. During the bathroom break, someone noticed that this robot seems awfully similar to one built at the North Pole. If they are the same type of robot, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of Christmas tree. Oh, this is the day. Oh my god, I see in the subreddit. I know the drama. What is the fewest number of robots that must elapse for the robots to display the Easter egg? Although it hasn't changed, you can still get your puzzle input. Most of the robots should arrange themselves into a picture of a Christmas tree. So I have to draw this out. And I have to look to the iterations. Very well then. I can draw this up. No big deal. Problem is, can I spot the tree? I haven't done this part yet, but I have some ideas how to proceed with it. My first idea, like the first thing I'm gonna try is gonna use the eyesight. Now, my senior told me to not. Oh, he actually did it. Son of a bitch. Because the problem is I don't know how to look for something that looks like a Christmas tree unless it's like a triangle or something like that. Into a picture of a Christmas tree. So in my head, a Christmas tree should be something like this. Or maybe not. You know, the funny thing is that I'm studying how to draw. So the disappointment is even bigger in my case. Okay. Like something like that and maybe once more, you know? This I would consider like the ashy art of a Christmas tree. So that causes me some issues. First, I'm gonna try and look what exactly does he qualify as a Christmas tree. I'm just gonna loop over like a couple thousand times, see what's going on over there. But the printing out of the so it would be like go line by line, row by row, and print dot and dash or hash. So that would be my pretty print. Let's put it up after the robot. So function pretty print. Love the whole community love for people sufferments. So people suffering. God damn it. Yeah, I only need the quadrants or the positions. No, actually, I need this to loop every time that I ask for it. So I don't need this part anymore. I don't care about counting anything, nor returning anything for that matter. Okay, so this is where we are at this point. Every time this shall move once. And in this case, I'm just gonna take the position, so the same idea as here. Young till here, young till here. I don't need them to be immutable. I can just take the reference. And yeah, I would also like to copy in these constants here. All right, for I in 0 up to rows, for j in 0 up to calls. By the way, I've sown the uproar of Reddit because I usually just take a quick dip on Reddit every now and then just to see how the advent is doing. So see, day 19 is people are getting caching EFS brute force solution. Dijkstra. So I like to get hyped for the next days. Now for Jane calls, I'm just going to say that if this coordinate is present in the positions, so if if positions not contains, god damn it, contains my coordinate, so contains chord of I and j, then we print out an hash. And of course, else we print out a dot. I'm missing a string data format. But of course, my friend. I don't know what possessed me to do a char, but fine. Okay, so I'm gonna pretty print it this way. I'm gonna also pretty print the current iteration. So let mute iter equals 0. Loop. And we're gonna move the robot every time by pressing it positions and speeds. Then we're gonna pretty print and this place it's an at. This is an at mute. And this is an at because why not? Equal friend is unreachable. Yeah, shut the fuck up. I know what I'm doing. Iter plus equal 1. Okay. But I'm going to thread it out a little bit. So thread. What was it? Oh damn. Oh damn. So it will be like a thread sleep. And it's going to be a time duration. I'm pretty used to do this. From milliseconds. God damn it. No, I didn't get used to it. Nope. Milliseconds. There you go. Yeah, why wasn't Rust telling me that? Ah, because it didn't import time. Okay. And I'm gonna say like 10 milliseconds so I can see something. For now, let's close. If I can type it out, let's close this up. Oh, right. Also. Oh, right. Should also print new line here. This is not a new line. This is not a new line. But this it is. Kinda fast. Also kinda big. Yep. Those sure are some robots. Honestly, I can see the disappointment. Mm. I think I need another terminal because I'm not gonna do this shit over here. Let's kill this for a second. Dude. The H. Oh, right. So workspace. Advent. And day 14. So the command would be run release 2. Do I have enough columns for that? Probably should like print a couple of new lines between each and every one of those. This looks like shit. Let's also Rust clean the terminal output. I can see that you're thriving on my supplement of day 14. Because I don't know a mathematical way to check for a tree. Because I don't know what the tree should be looking like. That's what I'm already frustrated, you know? I'm already upset. Print 14.2 is the best. Oh, so there's a lot of people gathering here to to see me suffer over this problem. Print as chart 27. Let's see if this works. I would like to lean every time the output. It would look more like that. Yeah, well, time to look. Can I zoom once? Can't. At this point, I'm considering getting some emojis in. Honestly, just take a guess. Most heuristic work. This one is my experience. Yeah. I'm just gonna emoji it for the memes. And then probably just gonna have to do something. Like, let's get the so emojis via tree. You go a Christmas tree. Looks fitting. Good. Amazing. And no. Sure, there has to be something better than snowflake. There you go. My muscle memory kills me. There you go. Wait, why are my rows fucked up like that? I did saw something. Wait a second. Calm the fuck down. I saw something. I don't know if it was a flash, but I saw some. Yeah, it sucks. Why are they so different? They're supposed to be like two spaces. How do I like why? Could have sworn that I saw them ganging up at some point. Can get the interaction. Is this the tree? Is this it? This supposed to be a tree? Yeah, because the space is not the same, sadly. I wouldn't define this a tree. But they did get ganged up over here. You'll be sure when you see it. Oh, okay. So I'm gonna run it in the meantime while I think. Because the first way that I can see, but I need something better because these guys are different from the social. I'm gonna put another kind of tree. Like, how about if I put like a palm tree over here? Probably gonna make it harder to spot, honestly. Well, at least trees seem to be in the same way. Is there like a red tree? Okay, I can do Thermopolis. Yeah, that sounds nice. My eyes are burning. Way too red. Is there any whitish tree? It's probably the problem from the. Let's take the evergreen tree. I like the Christmas one, but it's harder to spot. With my muscle memory is so hard to. Okay. In the meantime, uh, my guess would be, now that I think about it, is to because he said to me that every robot during the buffing notice if they're the same type, they should have a hardcode Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. No, most of the robots. How much would I consider most? Because it's not all. I could try and say like if 50% of robots are close or something. Yeah, more than 50% I get that's going to be like a good number. So let's then my first line is always messed up. Okay, I can go with that approach. Which in this case means I would make like a so this should become then a BFS or a DFS. Works both ways for the robots. Gonna keep the pretty print. Do I have to build the matrix and do the BFS? No, I don't think I have. The whole visited stuff. Oh, I just have to check if there's a robot close, right? Check every robot. There's at least one close. Move up. Now I'm gonna get into loops. No, 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 no. I don't want it. I don't want to build a matrix right now. I really don't feel like it, but okay, let's go. So my move robots is gonna get me the state. I'm gonna have to make the matrix. So let TMP equals get rather than get pose will be next frame. I call it like that. And we'll take my positions. And then god damn it. I'm gonna also so this is my frame. I'm gonna check if the frame robots. I'm gonna take the tree function, which will check if it's tree. So actually I'm gonna say yeah. God damn it. So let tree is going to be a boolean of check for tree with my frame and my positions. And if tree, then we can pretty print and break. Also my res is probably going to be res equals 1. Okay. Sounds like a nice stuff. So next frame should also... I'm just gonna copy them. Can't be bothered. Okay. So next frame should make me a matrix of coordinates. No. Should make a matrix of emojis. Yeah, emoji sounds nice. Emojis are strings. Yeah. No, that's a print. Make it strings. Fuck it, don't care. Should be also cars, but that's to byte. Should be strings. Okay. This is a vec of string. I could also, since I know how big it is, does this work? Like, if I say this, then 103, or rather 103 this. Nah, gonna look at that later. And then let frame equals simple vec. Let row equals a simple vec. Same loop for I in 0 to row, 0 to rows, for j in 0 to calls, row dot push. Yeah, I should push the emojis, so I should take a look in my trusty wait, stupid, I have the positions. If position contains the position contains a coordinate of I and j, then frame wait, I have to define it better. How would I find a matrix? Like I know I can do this way. So vec and vec of string. But I also want to initiate it to be the rows and calls. Should be like vec of 1 of 3 and like vec 101 or some shit like that. Rust define other way around. Oh, okay. In this case, would be like then z or other empty string 101. Of course, it's a string. Okay, so this would be a matrix 103 times 101. Looks nice. And shut the fuck up, please. Okay, so frame I j is going to be equal to a Christmas tree. Else string, what's that? Cannot be indexed. Oh. Well, silly me. Dude. Of course, it's immutable. My bad. There you go. I really want the snowflake, but whatever. I can use the tile, the white tile, because we use this for the guard day. The fuck is this white tile? For the guard day, white large square. Yeah, why not? Me and my friend, we use the flames to where the guard was moving, a brick for the obstruction, and a white tile to get it done. It was very cute. I actually have the video. I'm gonna take a look at it, show it later. Okay, so this will generate my. So this generates me one frame. Oops. Gets me one frame. Now I have to check. Now I would have to check if it's a tree. This is simply a BFS into what? That's a curious way to say it. Back of string. Okay. Now it's time for the BFS. Which now that I think about it, I should make it be. Well, I could use the string to be like checked. I can do that. Other way around. Oh no, wait, my bad. None of space, thank you for the follow. Now, I should be using a bool to say if it's had been visited, but I can just say like what emoji I can use for visited. You know what? I'm gonna use the Italy flag. Because I'm a Mamma Mia. Well, actually, I live in Mamma Mia land. So that is happening. Oh, damn. Doesn't get it? Okay. Weird. Wait. Maybe now he gets it? Dude. Okay, I'm not so sure that it understands it. I can go with the pinched finger. Okay, that's better. Flags are multi-symbols. Oh, makes sense. So wait, if emoji is 2 bytes, flags are 4 then? Or more? Alright then, BFS. At this point, I should be able to do a BFS. Like I should. Truly should. It would be. I want to do it in interactive, so let's BFS non-recursive. Queue to maintain the BFS order. List times to look for duplicates. The algorithm is in queue the initial point of the graph. If the queue is not empty, the queue and queue all neighbors, print the queue element, repeat steps 2 or 4. You can find many explanations here. Okay, so I can start from anywhere that's a position. No, wait, but I have to check if... Yeah, I would want to have like a max. So for pause in positions, if pause is different than Mamma Mia, I would in Q. I'll make Q be by element. Yeah, probably. Because then I would want, I want to take the outside for the, let's say, let bound, which should be half of the position len. Okay. And also count. Immutable. We would return false by default. Okay. So let Q equal back. If my position is Mamma Mia, then we will continue. Oh, my bad. Frame of pose.0, pose.1. As you sides. And as you sides. Very well. So if I already visited, fuck that. Otherwise, I'm gonna push my Q. So Q.push the current value, so pose.0 as you saw, pose.0. I can just push pause. Very well. And while Q is not empty, while my Q is not empty, I'm gonna do the loop over and get neighbors. So let neighbors equals, oh, sorry about that, I have to do a little check on my servers. Excuse me a second. Okay, so neighbors could be a simple get neighbors. And I'm gonna give it the frame and the pause. Of course, I'm gonna also have to pop it up. So let cur equals u dot pop dot unwrap. God damn it. I said unwrap. Okay. I'm gonna say Actually, I like calling it node. Sounds more intuitive to me. Okay, so my node for Gepur in neighbors. Rather, I have to also check if this is not visited. Actually, I should say that it's visited. Wait, if it's not Mamma Mia, go ahead. But then at the same time, we say that this is a Mamma Mia. So presumably, I just have to say it here inside. I get the neighbors if. Same thing here. But the opposite. So if it isn't, then this is happening. And we would want to put it into the stack, into the queue. Right? That's what's happening. You get the neighbors, you check the neighbors, and then you get the neighbors of those. Enqueue the initial point. If the queue is not empty, dequeue from the queue. Enqueue all neighbors of the queue element and insert them into the set if they are not already present in the set. Print access. Yeah. Okay, so we enqueue the neighbors. So queue dot push my neighbor. Very well. You just need to do this. And one neighbor would be anything in any corner that I can get if it's valid. So I'm gonna return an empty vec every time that we're out of bounds. The return would be gonna be like a vec of coordinates. So if node I like to make the up, down, left, right. So let up equals node.0. Actually, I can do node minus chord -1, -1. I hate these cases. Yeah, I'm getting the tiresome of writing these cases. So up, left, up, left, up, right. And then down, left, down, right, left, right. There are 8 of them, yes. And that would be, this is very annoying. So up is just -1. That up left is -1 as well. Up right, we're moving 1 call. Yeah, shut up. Okay. Down plus in X, we're not moving the call. Down left plus in X. Okay, this is 0. This is also 0. Okay. So we go down, we move 1 X, we go down left, move 1 X, and we also go back by 1 column. We move down right, 1 X and 1 Y, and then left will be only the Y and 0, 0. Something of those sorts. Now, oh my god, if node can I check? Oh, I should be able to check it like that, like this. Let's say let 0 equal chord -1 lower bound an upper bound would be at calls are 101 and 103. Okay. If up is bigger, by the way, I can macro this thing. I'm pretty sure I can. First of all, let's write it down, then I'm gonna macro it. It's gonna be very fast. Okay, if up is more than lower bound and up is less than upper bound, then we let neighbors equals vec. Then we vec dot, then we neighbors dot push neighbors. Then we push up. To the neighbors. Now, we can do this like that. So I'm gonna start from the line, get here, yank this word, go jump once, say if whatever I have here is lower bound and whatever I have here upper bound, my bad, bound. Then we can say neighbors dot push whatever I have here. Then we close it up, then we give it a space. And I should be able to get back and got here, Q. So let's try it down. Amazing. Forgot to check. Forgot to check about the symbol. Right. Ah well. So if it's in bounds, I can just check frame dot right dot 0. I'm gonna macro this as well. But frame dot right dot 0 and right dot 1 should be equal to my lovely Christmas tree. Now I do realize this should be a constant, but that's okay. For my new keyboard, I still am kinda with the sides. Okay. Then we start again over here and QQ. So we W, yank the word, frame, word 0 as your sides, right dot 1 as your sides, equals equals well, yeah, well, damn, let 3 equals this is a lot of work. Like today is a lot of work. Which also realize it should be here. Surely there's a more efficient way to do this. Probably. Might be. But this sounds like kind of standard DFS. But your sarcasm implies that there is. Ah, well. It is what it is when you get the idea. Okay. So, QQ. Yank the word. Get the light. Like, couldn't you just put all of these potential neighbors in a vec and iterate through them? Oh. Yes, I can. It feels better than you think about it. Actually, the funny thing is I got so pissed up at this problem that I actually did do this some another time. God damn it. Let pot neighbors. I don't remember which day, but I did do it that way. So I don't know why now I'm not doing it. Delete word xs pot neighbors dot push. Not the upper bound and not the lower bound. For in potential neighbors. Yeah. This is what happens when you get tired of shit. So nay that lower bound, nay that upper bound. Can't tell you what possessed me to do this. Of course, it's not immutable. My bad, Rust. Sorry about that. Okay, and at this point, of course, he wants a reference. No big deal. Same, also reference. Mispatch chord. Okay. And I'm just gonna put the count to start here. Okay, of course it's immutable. Sorry about that. Okay. So the count to start. Yeah, sure. Give the total ring enough. I can clone it. Big deal. What's this? Mismatch type, chord and chord. Consider borrowing. I'm gonna borrow it and he will get pissed because temporary value dropped while borrow. Consider using a let to create a longer lead value. Let longer. Still doesn't live long enough. Son of a bitch. Wait, why am I getting these problems? Why was the Q referenced again? What do you mean? Borrow later used here. What do you mean it wasn't referenced again? I'm using it here. Q.push. Oh wait, this is a pop. Okay, we push the Q, yes. Borrow later used here. And I'm Q.pushing here. Like, why do you need to keep reference and not just the actual value in there? Actually, did I put a reference here? Oh, my bad. Now that explains it. I didn't realize I was doing it that way. Cannot be the reference, sure. It's a big deal. Okay, and now the count would get up for every neighbor. Count pass equal 1. And I can say if count is bigger than, what was it called? Positions. Dot len half. Then we can return true. Actually, I have the bound. You know what? Fuck the bound. Yes, mutable reference. Calbro mutable frame as mutable. Can I clone a mutable reference of that? Because I need to mutate it, but I do not care what I do with it. Okay. This sounds fair. They mean remove this mute. Does this work? Oh, so first iteration works. Okay, I'm gonna print out to see what's going on here. I think I'm not checking it correctly. It looks like any infinite loop. Get the neighbors. So next frame. I'm stuck somewhere. Is it the next frame? Quite unlikely. then must be the 3. Okay, check 3 is not doing its job. As for pausing pose, let mute Q, vec, whatever. Pushing the Q, so if it's not Mamma Mia, is it because I'm doing the wrong way, like to string? I should do it, let Mamma Mia at this point. Let Mamma Mia equals, I think that might be the problem. Mamma Mia. Okay, wait a second. Demo structure. Where does this goddamn... Ugh. Okay. Wasn't that? So I'm stuck. Rust. Yes. Sometimes it's just Rust. That's what I did. Sometimes like there was one time when Rust didn't want me to do something, and I did, and it didn't work. But sometimes you're just like, I want to write code. Please let me write code. Let me do what I want to do. So the node will pop everything. I'm gonna get the neighbors. I'm gonna check the Gabor. If it isn't there, if it isn't checked, you put checked, and then you queue the Gabor. That sounds like BFS algorithm pseudocode. And this is the not. Yeah, queue. Make the queue, enqueue, mark as visited, done. While it's not empty, the queue for every W of V in graph G. If V is not visited, queue and mark as visited. Oh, this is why. Classic misplay. It's not one. The len is 101, but the index is blah blah blah. At 119. Did I invert the upper and the lower bounds? Probably. Oh. But that's weird. This is an overflow, right? Which means that this one didn't work. By the way, this should be greater than or equal. That's interesting. How about I print it out? Anyway, this year, doing something like this, getting every operation up, it was a given because, my God, did we do a lot of 2D puzzles. So 31 minus 1. There's should be falling in my check, right? If neighbor is bigger than lower bound, the lower bound is 0, 0. Did I not implement the greater than? This is checking only once. What would be? What's the trait? Partial order, equal partial order. That now works. It's out of bounds. Son of a bitch. Imp ord for chord. Get it up. Can't compare the trait partial order is implemented. Implement partial order. Wait. I can drag this out over here. Okay. And I will simply return what is self and other. Self.0 greater than self.1. Wait, how is this ordering? Less equal greater. Okay, I see. So if self.0 is greater than other.1 and self.other.0. Okay, didn't type. And self.1 is greater than self.1, then we return ordering greater. Else if then we're gonna return less and by default we're gonna return equal. Probably not a good idea, but nah, this just looks complicated. I didn't think it through. It's fine. Just check it up the good old way. So if nay.0 is more or equal to lower bound at 0 and nay.1 more or equal to lower bound at 1, also nay.0 should be less than upper bound at 0, and the nay.1 should be less than upper bound at 1. Long list, but it works. This means the bound is 101. It a strict one though. Less than upper bound 0, less than upper bound 1. They mix them up. The only thing that I think is like this one. Okay. Shouldn't print all of that. Just going to print the iterations. And let the fun begin. It's gonna stop eventually, right? I'm tempted to make it run, I don't know, 10, 20,000 expression. I can make it run like 5 minutes. Okay, maybe it's more. Does anyone have an idea of how much more? Well, since the grid wraparound should repeat after 1 or 3 steps, roughly 10,000. Oh. Then this means my algorithm is balls. I can check if it's going in a loop just by simply taking a look at the tree at my count. Like my count should give me indication of so it was 1. I might have messed up. Makes me wonder, shouldn't it then be here? No, it should be in the queue, right? Because I'm gonna still visit everything this way. This raises some questions. Bunch of ones. It's interesting. This is when my queue is always empty. Okay, let's run it at 10k, but it never gets different. Or I just print way too many of them. So let's say if count is bigger than 1, then we print the count. Because all of those ones are isolated, so I don't quite care. It doesn't look like it. Yeah. This is not how I think my Tuesday morning would be. Or Thursday, I should say. The other way that I could, well, not that this does anything really. The other way I can look at it is just to get a pretty print of the frame. Alright, my pretty print was smarter than that. Fair. Pretty print version 2. So frame, good old for row frame for L in row. Print, actually print and back. And we print our L. And we print a len the new line, and we print once it's done. Should be mutable because I don't care about mutating it. No, back to the big square, back to the big screen. Like here they touch, so my algorithm is balls because it won't ever print anything. Like somewhere, some way. Yeah, I see some. Like there's a tree here. So my way of accounting for that is incorrect. Not surprised. Big, little surprise. Why though? Like I could just put the count here and see what's going on. Maybe remove the pretty print so. Like my supposition, where the fuck was my function? So my supposition for this was that the way I see it, every time that I get a pause and I can push it in the queue, well then every single time my queue run up until we see all of the neighbors. That's why I thought it this way, because up until the queue is empty, we get the neighbors. So there should be some problem in me getting neighbors. Like if I print neighbors and say that we print the neighbors.len, this shouldn't be always 1. Well, there you go. So basically, I'm not getting any neighbor ever. Actually, I'm gonna print if neighbors.len is more than 0, then we print it. Here and there I should have some 1, 2s. No, I do get some neighbors. Maybe more than 1 is intelligible. 2 and 3s. I'm getting some 4s and 5s. Okay, so this way, this function works properly. The next thing that I can check is how much I pass inside the queue. Which honestly is what I do. I count while queue is not empty. I mean, I could probably invert this. Don't think it makes that much of a difference. Nope, I don't invert this. Am I stuck? Does this function return? I think yes it does. Okay, I'm not stuck. Now that's interesting. So this breaks every time. Doesn't even get ever visited for every neighbor W of V if V is not visited in Q and then Marcus visited. And it's super bizarre. My stuff never prints more than one. Because I'm... Oh, it should repeat after 100,000. Oh. So what you're saying, I should be going up. I thought 10,000. Well. Am I right this way I work? See what's going on. No, that's 10k. That's 10k. Yes, it's 4. Okay, so it doesn't work. I am stuck then. At least I know where the mystery is why my count is never more than 1. Because the count should be at the very least sometimes. It could be at the very least sometimes more than 2. But it looks like I put one neighbor and I can't queue anything. Check if you're pushing to the queue ever maybe. Yeah, this is one thing that I probably could check. I'm gonna just print in here the queue. Should be like growing sometimes. Never pushing it. If it's not visited, and something that's visited is Mamma Mia. Am I never Mamma Miaing it? Okay, I'm never pushing. So thanks for that. That's not happening. Wait a second. Got copy pasted. Yep, I got copy pasted myself. Same goes here. Gabor. Gabor. Let's run it now. Bro. I have a couple of minutes. Then at 10 I need to go to work. which means turning down the main PC and checking up the portable one. Maybe 50% is more than... Like, how about we say if count is bigger than 20? Yeah, but if you say most, you say... By saying most, you mean most. Like, most would be MacW, NQW, that's a 29, 21. Wait, this 2029? Fuck is this shit? 229? How many robots do I have, by the way? Like, how much are we saying? Robs. Positions.len. So they're to 300. I think that's pretty close. Wait, how did I print it? I just deleted it. That's okay. So 229, it's still not most. But I wanted to print it out when it's more than 200. I could use like, it's more than 200. Can print the count. I can use the pretty print suit to print the frame. Shouldn't be terribly wrong. At least it shouldn't. That's him! 229. Dude, that's beautiful. The Mamma Mia tree. Looks like a tree to me. Yes, it does. I hate that there's one tree outside, but damn. I'm gonna say, this puzzle was upsetting at first, but I loved it. Like, the Mamma Mia tree merits a screenshot. I'm gonna send it to my girlfriend later. So that's amazing, man. Got the Mamma Mia tree. So it's 229. I had the feeling that it's 229. Anyway, when he says most... Wait. Isn't this 229? Did I mistype? Wait, what was the question again? Need the frame number. It said too low, so it's going to be 230. Ah, I believe it said too low. Can't check the vote, but I think it said too low. Man, that does look good. 221 is the robot count. God damn it. Thanks. I was starting to get very upset. So if count is equal at precisely 229, return true, and we need a frame, but yeah, I'm gonna do it like this. Damn, gotta say, I'm happy with the result. Except this bastard. But I'm supposing this is as good as it gets. Still impressive. Have the Mamma Mia tree laid out like that. So 6, 2, 4, 3. Six, 2, 4, 3. Well, guys, thank you for the help. Today was wonderful. Let's check first off how many are over here because I don't have the numbers down where my modules won't load. There are 4 of us, which means we should raid somebody else. Ideally, someone which already does Advent of Code in Rust. Software and game development. Brother. There you go. Advent. Okay, so the closest I can get is the 7 viewer Turkish. Okay, let's get to the 9 guy. If all 4 of you will come. Advent of Code, so SCL. Raid channel. Well, guys, you have been wonderful. Thank you for today. Thank you for the help. Man, what's up with the